Hello 8th graders, in this IXL support video we're taking a look at F13 towards the end of our exponent work called Identify Equivalent Expressions Using Exponents. So what's going to happen here is, again this time, kind of like F12, we're going to be using our properties of exponents to do some work with exponents, but instead of evaluating all the way, we're just going to find which expressions are equal to the one we start off with. But it's going to be a lot like F12 in that we need to know these different properties for multiplying or dividing with exponents, and then how to use those rules. So for our first example, we see which expression is equivalent to 11 to the 8th power times 11 to the 7th power. And here I want to be thinking about my multiplication with exponents rule. Whenever I multiply the same base, I can just add those exponents. So I'm going to go ahead here, and I'm going to do 8 plus 7. Which equals 15. So the fact that 8 plus 7 equals 15 is what tells me here that this expression, fix that, 11 to the 8th times 11 to the 7th must also be the same thing as 11 to the power of 15. And we can see that options right here. Go ahead selecting that and moving forward, as we think that one's pretty straightforward. For this next example, we would encourage you to do this on your own. It says who is equivalent to 4 squared times 4 to the 8th power. So try to figure this out on your own. Pause the video if you need. And as you're coming back, hopefully you're saying, Mr. Doherty, this is very similar to the one we just did. We're multiplying the same base. We're just going to add those exponents up. So 4 squared times 4 to the 8th is really just the same thing as 4 to the power of 10. And that's how we're grabbing this answer right here. Here's the next example, and again, a different rule now, a different property, but we're going to be thinking about which property of exponents helps me simplify and find the answer. So pause the video, try to do this one on your own. And what I would encourage is you're coming back from pausing the video and finding your answer. Hopefully we see that this is the exponent to exponent rule. Or whenever I apply exponents to another exponent, all I need to do is multiply those exponents together. So in this case, 11 to the 7th power, all raised to the power of 7. Quite simply, I could just go ahead and do 7 times 7. That equals 49. So that's telling me, if I do 11 to the 7th raised to the 7th power, 7 sets of those 7 11s, I'm going to have a total of 49 copies of 11. This one I would definitely encourage you to do on your own, building on a very similar skill that we just did. Hopefully a lot of you are saying, Mr. Doherty, it's the exponent to exponent situation. All we need to do is multiply those two exponents together. 7 times 5, which equals 35, tells us in this case 2 to the power of 35 is the answer that we're looking for. So selecting 2 to the power of 35, submitting that answer, and I think we're in strong shape. Now, here's a pretty good one. I'm going to go ahead and do this one out with us. This gets a little more challenging, and we're up to the 40s. They're starting to make us think a little more. Here we see a different base. So the first thing I'm going to do is I can't multiply these together with the rule, but I do want to switch them over towards positive exponents. And you don't have to do it the way I'm doing here, but this is at least helping my brain think a little bit. And now I see something. On the bottom in the denominator, these are both raised to the power of 3. A bunch of 2's, 3 copies, a bunch of 3's, 3 copies, and I know 2 times 3 is 6. So there's one other property we didn't show a lot in class. If you have 2 different bases raised to the same exponent, you can multiply the bases together. 2 times 3 is 6. And keep that exponent. The reason that works, if I have 3 sets of 2 and 3 sets of 3 multiplied, and 2 times 3 is 6, I'm going to have 3 sets of 6 when I multiply all those 2's and those 3's together. And so that tells me here that 1 over 6 to the 3rd power is our correct answer. Other people may have first gotten to 6 to the negative 6th power. They may have seen to the negative 3rd power and then pulled it down to here. I do think it's easier to flip them to positive exponents first, but either way would work. This is definitely a trickier question, and we should have done a better job teaching that in class. Different bases, same exponent, you can multiply the bases together. they're building on that again, and it looks like we need a better class lesson for this. We'll try to find some examples like that. But if you ever have different bases applied to the same exponent, this is new to me from IXL, you can kind of go ahead and just say, wait a minute, if 2 times 10 is 20, then 2 to the negative fourth times 10 to the negative fourth, same exponents, is just going to be 20 to the negative fourth when we multiply all the 2's and the 10's together. And I know this is the same thing as 1 over 20 to the fourth power, and that's how I'm going to end up finding my correct answer over here. I'm going to skip ahead now at this point. We're getting pretty far into the video. We think, as challenging as F13 is, pulling many different rules, we think you're in good shape to do F13. I want to skip ahead and see if in the challenge zone or the more difficult ones, how they make it more of a challenge. But we think you're in very good shape to stop this video. Keep moving. I'm going to show 1 or 2 from the higher range, but it looks like they're all challenging at similar levels here, whether you're in the beginning, middle, or end of F13. So this one is challenging, but similar skills. I'm going to apply the exponent to exponent. Hopefully you all at home are saying, wait a minute, I just need to do 4 times 3. And that's going to give me 9 raised to the power of 12. But to get there, I just did 4 times 3 exponent to exponent. And now this is why this is more challenging. None of these say 9 to the 12th power. And this one is not the same as 9 to the 12th. I could say 9 to the 12th is the same as 1 over 9 to the negative 12 if I wanted. But that's not this one. So I need to think about something that they showed me earlier. Here I see the exponent of 12, but different base is 3, but 3 times 3 is 9. So it turns out that this right here is also the same thing as 9 to the 12th power. So they're making it more challenging at the end by making you do this rule straightforward, but now you got to think of it. The answer didn't show up. Which answer is the same thing as 9 to the 12th? Oh, it must be this one right here. And I like how IXL is making that more challenging. It is more difficult for sure, and I didn't see that at first. Now here they're making you think a little bit too, ooh, this is a great problem to talk about in this video. And I'm going to rephrase what I said earlier. This gets very tough at the 80s, and I'm seeing how they make this more challenging. First things I'm going to do, I'm multiplying the same base. 0 plus 3 is still 3, so I could say this is the same thing as 6 to the power of 3, or 6 cubed. You could also just call 6 to the power 0 1, because anything to the power 0 is 1, and 1 times 6 to the third would still be 6 to the third power. And now we're saying, wait a minute, none of these here say 6 to the third power. 1 over 6 to the third is a very good distractor. It's not the same thing as 6 to the third. They're hoping you pick it when you see none of these say 6 to the third. Now they're also building on something. I know 12 divided by 2 is 6. So if I do 12 divided by 2, and that makes 6, and I have 3 sets of that, I know 12 to the third over 2 to the third is just the same thing as 6 to the third. So that might have been tricky to see at first, but 6 to the third power, same exponents, I could go ahead and divide those base terms, just like the division suggested, and keep the exponent the same. I'm going to show one more because I was inspired by how tricky they're making some of this, but I also think that as you get to F13 and into the 80s and 90s, you may need a little help, and it's okay, email me. 7 to the 30th over 7 to the negative 6, I'm just going to go ahead and do 30. The base is the same in the top and the bottom, so I'm going to do 30 minus the negative 6, because I know the property of exponents says I can do top minus bottom when the base is the same. That means the same thing as 30 plus 6, so I'm going to get 36 out of this whole situation. So I'm going to end up with 7 to the power of 36 here for my answer. Now what I need to understand is this is a positive exponent. If I shift it down into the denominator, which means division, I need to take the reciprocal, or the inverse exponent, which is the negative 36 power. So this isn't helpful. This is way simpler to say 7 to the 36th, but I could convert it to 1 over 7 to the negative 36th, and that kind of tells me, wait a minute. This one right here is the same thing as this one up here, even though we might not see that right away. Now, this is challenging, so if you do have any questions, please don't be shy. Feel free to email me, and my email address is now on the screen. That's ddoherty3, and that's always at bostonpublicschools.org. And you're welcome to send me a GChat or an email anytime you want to work on this one-on-one, this definitely does get challenging. Thank you for watching to the end of the video. Thank you for working hard to get to assignments like F13 that are very challenging.